Alright, what's up everybody? Welcome to my second video on basic computer engineering, which is just sort of how computers work is essentially what I'm going for. So whether you're interested in it for purely professional reasons, right, like you want to learn what you need to learn to be a better engineer, or whether you're just sort of interested in how computers work generally, because it is kind of crazy to think about how computers work, this technology we have that we sort of take for granted now, but is hugely complex and took a lot of really smart people doing some pretty crazy stuff. So uh, anyway, I started the last video talking about Morse code, which is sort of ancient history in terms of computer engineering stuff. But it's sort of interesting because it's sort of foundational, and a lot of you can sort of see the evolution of a lot of the computer science concepts. So I wanted to do one more quick video about Morse code before I move on to you know wires and things, electrical engineering, and that was sort of from the perspective of the receiver, right? Because we had a video where we talked about how to send Morse code. So, and I have this chart pulled up that I got from, learnmorsecode.com, which is just, I Googled it and found it. And there's literally hundreds of these charts out there that you don't really need, because honestly, you're probably never going to send Morse code. But if you had a chart like this, you wanted to send, like, what's up, right? You just look for the W and then you say, oh, this is a dot dash dash. So you send dot dash dash. Then you find your H and you send, dot 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 dot. And then you find your A dot dash. T is just one dash, and so on. But if I'm on the other end and I'm trying to receive this message, right, I might not have all of these dots and dashes memorized, right? I mean, I guess if I was a professional Morse code receiver, like maybe eventually I would sort of memorize them. But for sort of the casual user, I get a dot dash dash, right? And I got to kind of look through here, like, where is dot dash dash, right? And then, oh, here it is, it's W. So I've got a W, but then by then, like, I kind of missed the next one that was coming in, right? The dot 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 for the H. So what we really would like to have, if we are on the receiving end of some Morse code, is like a quick way to look up the letter for the Morse code that we just got, right? So like if I get in a dot dash dash dash, I want to be able to look and find that very quickly. And that's where this term binary trees is going to come in, because one way we could do it is I could tell you to hold on a minute while I look this up, letter by letter, so that you won't send your next letter until I confirm with you that I'm ready to receive the next letter. But that could be very slow and very tedious, so we'd rather have some sort of a quick lookup way. And that's what the binary tree is. And the binary tree is based on the assumption, which in Morse code is correct, that there's only two possibilities of symbols that you could get in any one situation, right? So we start at this sort of top node, and even though it's called a tree, it's going to kind of look like a root system because it starts at the top and spreads out. But they're called trees, even just think of them as upside down trees, whatever. So we've got two options, right? In binary, we have two options. We've got our first letter can either be a dash or a dot, right? And we know that if we get just one dash, right, then we have a T. And I'm just going to leave that there. And if we have only one dot, then we have an E. So if we get just one dash, we know we have a T. If we have one dot, we know we have an E. But let's say we get two, right? And we were talking about this in the last video. Well, let's say we got two, and the first one we got was a dash. Then we know that we only have two options for our next one, right? Assuming we already got a dash, then we know we can only get another dash or we can get a dot. And similarly, if our first one was a dot, we know we can either get a dash or a dot for our second one as well. So we know that if we get a dash and then another dash, then that's an M. If we get a dash and then a dot, then that's an N. And if we get a dot and then a dash, that's an A. And if we get a dot and then another dot, then that's an I. And I'm going to run out of space here, right? Because then the next one would be, two more down like this. And I'm going to run out of space, but I'm going to pull up this more neater version, printed version here, this one, right? And they're using essentially the same thing, only they're saying da and dit, which, remember, dash and dot is just the way that you write them, and I'm using the terms dash and dot because, I know what a dash and a dot is, but it's not really you're sending a dash or you're sending a dot. You're sending either a long signal or you're sending a short signal. So da and dit was another way to refer to the long signal versus the short signal, right? Because it's sort of phonetically, a da sounds long and a dit sounds short, right? So a da is just a long signal similar to a dash, and a dit is just a short signal similar to a dot. So, and you can see that the tree as I started it looks the same as this sort of top level of this tree, and then it continues down. If you get dash, 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 it's a O. And then if you get dash, 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 dot, or da, 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 dit, then it's a period, right? So we've got some punctuations in there as well. So that's great. I didn't really go over the punctuations in the last video, but it doesn't matter. Anyway, the point here is that we're doing what's called traversing a tree. And what that means is that why this is good rather than, just using the other table and just trying to look up this, is that we don't have to look up the whole string, the whole series of signals, right? We only have to remember, or we only have to really care about the next one coming in. Because if I get a dash, then I go here. And then I don't care about that anymore. I can forget about that and just wait for the next one. And if the next one is a da again, then I move here. And then I don't care about anything that came before that. I only care about the next thing that I get. And if it happens to be, a dot, a dit, then I go this way. So every time I get a new signal, if it's a da, if it's a long signal, then I traverse down to the left one. And if it's a dit, if it's a short signal, then I traverse down to the right one. And then whenever it ends, wherever I am is the symbol that I got. So we're doing sort of a binary tree traversal there. And that's cool, and that's becomes important in computer science in a lot of ways, right? First of all, because binary trees are still in use, because binary trees have this sort of property where they make searching through what's called a data structure fast. Searching a data structure, right? Because computer scientists are always looking for new, faster sort of algorithms and ways to hold data, right? Data structures. And data structures is a big topic, and obviously I'm not going to go into all the details, right, in one video. But essentially what it is computers are very fast, right, and they can do calculations fairly quickly, especially when compared to their human counterparts, us fleshy mortals. But if you're doing really big calculations with millions and millions of iterations of different things, you can see that even nanoseconds can add up. So using some sort of data structure which sort of more optimizes the time it takes you to find something or add a new piece of data to your data structure is going to be making your code much more fast and efficient. And we can see in the in the use case for just the guy who's using a binary tree to look up the letters as the Morse code comes in, he finds it much quicker and easier to traverse the tree one at a time as it comes in than to sort of get the whole message and then try to linearly search through all these until he finds the right one. So even back then they were using these different types of data structures to describe the data that they were using. So anyway, that's a interesting tidbit. Obviously, there's a lot more to cover in this area, right? But that's sort of for another video. So I'm going to leave Morse code alone for a while because I think the next couple videos we're going to move on to sort of early electrical engineering stuff, because computers are at the end of the day electrical devices. So the history of computer engineering is also the history of electrical engineering in many ways. So anyway, bye for now.